Hey AP Calculus students, welcome back. Today we're looking at 8.3 part 2. We're still doing volumes. We're going to do a little bit different ones today. So the first example says we have a region bound by this function, y equals 3 square root x over 4, the x-axis, and x equals 4, and it's revolved around x equals 4. So let's go ahead and graph this 3 square root x over 4. So we have 3 square root x over 4 so we're looking at this graph and it's bounded by that graph, x equals 4, so x equals 4. Okay, by that red line and the x-axis. And what's happening is we're rotating it around that red line, x equals 4. So let's go ahead and draw that out. So it looks like this on one side, right? And we're rotating it around this axis, so it's going to look like the same thing on the other side. And because it's rotating around that line, we're going to have the circles stacked up vertically. Right, so let's go ahead and figure this volume out. So the key for this one is if we do this in terms of x, then we're not really chopping them into circles, right? If we were doing it in terms of x, we'd be chopping them, let's change colors here, this way, right? Because this is the x-axis. And our bases wouldn't be circles. They wouldn't be anything that we really know the volume of. So we really can't chop them up in that manner. So we're going to do this one with respect to y. So with respect to y. Okay, so let's kind of set this up. So what we know here is that the top is going to be at 3, and we can go back and check our graph to make sure. So the top here, the intersection is at 3, right? Because we're talking in terms of y. Whoops. So we know this is going to be at 3 for our y, and the bottom is at 0 for our y. So we know our integral is going to be from 0 to 3. Now the trick is we need to figure out how we're going to set up our radius, right? Because we're working with circles again. We know we have pi r squared, right, with respect to y. So we need to represent our radius with respect to y, which is a little bit tricky. But if you keep this in mind, then we should be okay. So notice that if we're talking in terms of x, then that's just going to be, each of these is going to be 4 minus x, because this line is at 4, this is at 0. So if we subtract whatever our x value is, then we get the distance from this axis of rotation, and we change colors, between the axis of rotation at 4 and the edge of our function, right? The edge of our function. So at the very bottom, it's going to be 4 minus 0, which is 4, right? So we know that this is going to be 4 units long. It kind of makes sense. Okay, now the tricky part is that because we're working in terms of y, or we want to be working in terms of y, we need to solve this for x. So we're going to do y equals 3 square root x over 4. We're going to divide by 3 to get rid of that 3. So y over 3 equals square root x over 4. Then we're going to square both sides, right, to undo our radical. So we have y squared over 9 equals x over 4. And then when we multiply by 4, we get x equals 4/9 y squared. So we can replace this x here with 4/9 y squared. 4 minus 4/9 y squared. So this is going to be our radius. Okay, let's change colors. So what we're going to do is we're going to do our integral from 0 to 3 of pi times 4 minus 4/9 y squared dy. And we could do this using a calculator, but I think we'll be all right. All right, so the integral of, we can take the pi out, right, because it's just a constant. And then we have 4y minus 4 over y cubed over 3, 4/9 from 0 to 3. Okay, so let's start plugging this stuff in. So 4 times 3 is 12 minus 4/9. 3 to the third is 27. Divided by 3 is 9. So 9 and 9, so this is going to be 4. Did I do that correctly? Oh, I forgot to square it. R squared. I forgot to do it again. Let's back it up. So this first derivative is not going to be very nice because then we have to do, well, we can't really use sub it. And we could multiply it out. You know what? Let's just do it using our calculators because it's just easier. Okay, so let's do math 9 from 0 to 3. And we're doing pi parentheses 4 minus 4/9. I'm going to put that 4/9 in parentheses as well. 4/9, just in case. X squared dx. Perfect. Okay, so we get 80.42. Ah, 42 units cubed. Okay, let me just check with the book. So they have 128 pi divided by 5, which is the exact same thing. Okay, perfect. Keep in mind we could go ahead and do the whole thing out, but I think for the sake of time, because we know how to integrate and stuff like that, we just have to use some strategies in order to do it. We might as well use the calculators. Okay, so that is one of the ones where it's weird, where we have a revolved around some other axis than y or x. Okay, and in this case, we decided to do our integrals with respect to y because then we have a stack of circles vertically, so it makes sense to chop this up with respect to y because we're stacking the circles vertically. Okay, on to the next one. So this one is shells. So for our shells, what we're trying to do is we're trying to fill in not cylinders, but the outsides of cylinders. So if we took the outside of a can of, I don't know, Pringles, that's what we're looking at. We're, the top and bottom don't have any, they're not filled in. So we're just looking on the outside, the wrapper. So for these ones, we're just looking at, if we unfolded this wrapper, right, it would be a rectangle. The top would be the circumference. And we know that the circumference is 2 pi r. And then the height of this would be, well, we'll talk about the height when we draw this out. So it says the region bound by y equals square root x and x equals 4 is rotated around the x-axis. Find the volume. So this is going to be x squared. I'm not going to graph it because this is pretty straightforward. And this is x equals 4. Okay, we're making circles this way. right? So it's going to look like kind of a bell shape, I guess. Okay, so this is just another strategy to find the volume. Let's change colors. So notice that we could definitely do this, and we could just stack our circles and we'd be fine. But we're going to just do the shell method. So rather than stacking circles, each of these circles is going to be a wrapper. Right, so we're just going to wrap these rectangles around each other, kind of like a toilet paper roll, but like an oddly shaped, like a bell-shaped toilet paper roll, right? Because if we wrap infinitely many papers, then we get the exact volume of our outside function, which is our bell-looking thing. Okay, so we're going to go ahead and do this. Notice that we're looking for the circumference, right? But the circumference for each of these is going to be determined by the height. Let's change colors here so that's a little bit easier to see. So the circumference in order for us to find our circumference, we need to find the radius. But the radius in terms of x is square root x. Right, so r equals square root x. And then our height is going to be this height here. Okay, so notice that our height is just going to be, the largest we're going to get is 4. And then we go all the way till we hit our function here. And the x for our function is going to be x, so 4 minus x. So each of these lengths is going to be 4 minus x long. Okay, so let's set up our shells, not washers, excuse me. Let's use orange. So for this one, we're going to do from 0 to 4, right? Because that's our x starts at 0, it ends at 4. And our integral is going to look like 2 pi r8. So 2 pi times r, which is square root x, times h, which is 4 minus x. Let's clean it up a little bit. So let's say 2 pi is outside, right? Because we can take any constants outside. And then on the inside, if I distribute this square root x, then I get, let's do it that way. I think it's going to be easier. So we get 4x to the 1/2 minus square root x times x is going to be x to the 3/2. Okay, and then let's continue let's do our integral. So 2 pi, and then we have 4 to the 1/2, so that's going to be 3/2, 4x 3/2 over 3/2 minus x to the 5/2 over 5/2. Kind of running out of room here. Let's simplify that. So that's going to be 8/3, right? If we multiply by the reciprocal, it'd be 8/3 x to the 3/2 minus 2/5 x to the 5/2, and we're doing that from 0 to 4. Okay, so let's use our calculators here. Two pi times the integral of we could have just done it from here. Okay, so times the integral of from 0 to 4 of 4x to the 1/2 minus x to the 3/2, x to the 3/2 dx. And then we end up with 53.61. 53.61. This doesn't seem right. 8 pi is 25. The radius is pi over x. The height is gonna be 4 minus x. Four to the 1/2, x to the 3/2. Well, anyways, the answer should be 25.13, but what I got was 53.62. I'm wondering, in the book they did it with respect to y. But we were doing it with respect to x. Which we should be able to do both ways. I'm not sure why mine didn't come out. Let me try to redo this. The integral of from 0 to 4 of square root x times 4 minus x. Dx. It still comes out weird. I might have set it up funny, but you get the idea. If we were to do it in terms of y, it would actually be a little bit easier. We can go ahead and do that now. So let's erase this. And then go back to thinking in terms of y. So I'm not going to erase this diagram just yet. Okay, so if we're going back here and we're looking at this in terms of y. Now this makes it a little bit easier. For our y, we're going from 0 to 2 because this top point would be at 2. So we know our integral is going to be from 0 to 2. We're still doing 2 pi. Now our circumference, we need to solve this in terms of y. So y equals square root x. So we're going to solve this for x. So we know that the radius is going to be y squared. So it's going to be y squared is our radius. And then our circumference, this is going to be a little bit different because we need to do this in terms of y. So what we're going to do is we're going to say that we do know it's 4 minus x, right? We said that before when we were solving in terms of x, but we're going to replace this x because we know x is equal to y squared. We're going to say y squared minus x dx. Oh, sorry. 4 minus y squared dx. Or dy. There we go. Okay, so same idea here. I'm going to take the 2 pi outside. And then I'm going to multiply the y squared. So 4y squared minus y to the fourth dy. And then we're going to integrate. This is a much easier integral. So 2 pi. And then we're going to do 4 y cubed over 3 minus y5 over 5 from 0 to 2. And then when we plug in here, we get 4 times 2 cubed is 8. So 8 times 4 is 32 over 3 minus 2 to the fifth is 32 over 5. And then when we plug in 0, we get 0, right? So we don't have to subtract it. So we get 2 pi times that. 2 pi times 32 divided by 3 minus 32 divided by 5 is going to be 26.8. 26.81. Okay, so that's what we should have got the first time. For some reason, when we did it in terms of y, it came out different, which I don't know why it should. It should still be good, but yeah. All right, this is the correct answer. And as you can see, it's a lot nicer and cleaner if we do it in terms of y. Okay, on to the next one. So this one says the region bound by y equals 4 minus x squared, y equals x, and x equals 0 is revolved around the x-axis. So find the volume. All right, let's graph this. 4 minus x squared. Sorry. Four minus x squared and y equals x. And the y-axis, right? So, and x equals 0. Okay, so notice that we're looking from here to here. So it looks kind of like this, and then like this. Is revolved around the y-axis, so it's going to look like this shape, and we're stacking circles. Find the volume. So in this case, because we're stacking vertically, we want to do this in terms of y, right? So we need to figure out where the top is and where the bottom is. So let's go and check our graph. The top is at 4, the bottom is at 0, so we know our integration is going to go from 0 to 4. And we just have to solve these in terms of y, right? And then we know that, well, let's figure it out this way. For each of our circumferences of our circle, let's do this as shells because this is going to be easier as shells. Okay, so we're not stacking circles, we're stacking these shells, shell method. Okay, so what we're going to do is we're going to use that same thing we did earlier, 2 pi r times h. And let's figure out what these things are asking us to find. So the r is just going to be the x, right? So this is going to be technically the x. So we need to solve this for x. So x is y. Now let's start over again. Wait, time out. Okay, so we're doing this as cylinders. And as these cylinders grow, right, so that's the top of the cylinder. As these cylinders grow, we're talking in terms of x, so we're not looking in terms of y. I apologize for that. So what we do need to know is we need to figure out the x value for where they connect though. Okay, so they connect at 1562. Alright, so 1562. Okay, and then this makes it easier, in fact, because, alright, now our circumference for each of these outsides of our circles is just going to be our x. So we have 2 pi times x. Our radius is x. And then our height now is going to be the difference between the top function and the bottom function. So the top function is our top function is 4 minus x squared minus the bottom function, which is x. And we're doing this from 0 to 1.562 dx. Okay, so let's go ahead and use our calculators to do this one as well. So we have 2 pi, and we're doing the integral math 9 from 0 to 1.562 of x parentheses 4 minus x squared minus x dx. And we come out with 13.327 units squared. Cube. Sorry. Okay, so we could do this in 2 parts, right? We could have done stacking circles, but we'd have to do the bottom part first, and then we'd have to do the top part second, because they're the outsides, the radiuses are determined by the 2 separate functions. But because we did our cylinders, we did our function with respect to x, because the cylinders grow outward this way, right? If we're wrapping a toilet paper roll, it gets bigger and bigger towards the x side. If we were to stack circles here, we could do the same thing, but then we would have to do our function and our integral with respect to y, because we're stacking circles vertically, if that makes sense. Okay, that's it for today. Hopefully it wasn't too much. These things usually take some time, so the more we practice, the better we get at it, and the more we see, the better we can find strategies. Do I want to use a washer? Do I want to use cylinders? Do I want to use circles to stack up? So all those different things we can use most of the strategies in most situations if we get really good at one, but then if we have different strategies, then many times one of those strategies will work a lot better and be a lot easier to figure out. So just keep practicing, we'll get better at them. Good job.